Okay, did you send me something or are you going to verbalize it?
It's pending right now.
Okay, here, let me pull it up. Whoops. Okay, my phone got it before my computer did. There it is. Whoops. I have to click on it. There we go. Where do you want to start?
I was kind of confused on 2, A, B, and C, so preferably there. I don't know if I did them right.
Okay. So solve them using the quadratic formula. What's A, B, and C?
For A?
A is what?
Oh, 2, and then -1, and then -1.
Okay. The quadratic formula is what?
X equals positive and negative B.
No. Just negative B, and then plus or minus.
Oh. Okay. Times the square root of B squared minus 4 times AC over 2A.
Alright, so now we just need to plug in. So what do we get when we plug in the numbers?
We get positive 1 plus or minus square root of -1 squared minus...
Hold on. Okay, I don't mind doing it like that. I actually think that that's probably a better way to do it, rather than try to take shortcuts.
Okay. And then 2 times -1.
Now, over
2 times 2.
Alright. Now, there's a really, you see this a lot, where C is negative, and the mistake that people end up making is treating that as a subtraction problem instead of a multiplication problem. So what I always recommend people do here is do that part next. Always.
Okay.
Then subtract whatever you get for that. So what do you get when you multiply those three numbers?
You get 8.
No? Notice what I've circled. I did not include the subtraction sign.
Oh, you get -8?
Right. And that's, I mean, it's easy to make a mistake here because you have so many negative signs. Now simplify that. What is that?
It's 1 time plus or minus square root of -7 over 4.
No, do each one individually. Always start from the inside out. What's -1 squared?
Oh, 1.
What's 1 minus a -8?
8, like a positive 8. Oh, 7. Wait, 7?
1 minus a -8.
Oh, it's 9.
Okay. So now, what does that tell us? What is our answer? 1 plus or minus what?
3 over 4.
The whole thing over 4. And what does that tell us? What's our final answer?
I never get how I'm supposed to write these answers. So what I just write them separately is 1.
Okay. Here's what you do. The plus is one answer. The minus is another answer. There's your two answers.
So then x equals 1 and then x equals negative 1/2.
Correct. That's how you handle the plus or minus. It just means two different things, and one answer uses the plus and the other one uses the minus. Now, the fact that these came out to be rational numbers means we probably could have factored that in the first place, although I don't see how. Maybe not. Oh, I was looking at B on the screen here. I didn't see how we could factor that, but A, yeah, A is going to factor into x minus 1 times x plus 1/2. So A, the one we just did, whenever you get answers like this, it means you could have done it by factoring.
Okay.
Let's factor it just for the heck of it, because you can never get too much practice at factoring. First step,
You can't take anything out.
okay. Second step,
Separate the x.
good. Separate the x squared term. What do we get when we separate those?
2x and then x.
Okay. Now, what is the next step when factoring?
We have to figure out how it multiplies to 1 and adds up to or negative 1 and adds up.
Really. Everybody wants to skip the middle step, and I don't know why. I guess maybe it has to do with the fact that they teach this thing like the California method, which I hate. But if you follow my method, you'll never get this wrong. The next step, step 2, is to determine what your signs are. Now, I can determine both signs. How can I possibly produce a negative 1 there? What do the signs have to be?
Opposites.
Correct. So it's either plus minus, but because my coefficient of the x terms are different, it might be minus plus, and they might yield different answers. If my coefficients are the same, then I could write plus minus, and that's all I'd have to write. But if they're different, I have to allow for both possibilities. Now, factors of 1, and that's all I know. Factors of 1. Those are the only two factors of 1. So we got 4 possibilities. We can put 1 there and 1 there, or 1 there and 1 there. That's really only 2 possibilities. Well, let's just try one. Now, does that produce the correct middle term? In other words, this is a trial and error process at this point, regardless of which method you're using. Even if you're using the California method or the diamond method, it's a trial and error process. And my method is a trial and error process. It's just that I find my method much less confusing than what they try to teach. So is that correct? The way we determine if it's correct is, does that produce the correct middle term? And the middle term always comes from multiplying the outside and the inside and adding it together. In other words, you're familiar with FOIL?
Mm-hmm.
The middle term comes from those two only. The outside and the inside. So what's the inside produce?
The inside produces 1x.
It's useful to put a sign on it. What's the outside produce?
Negative 2x.
Add them together, what do you get?
Negative 1x.
And that is our middle term, therefore we did it correctly. And that's how you factor. And these are hard factoring problems when it's not a 1 here. In other words, there's two kind of factoring problems. There's the lowest degree of difficulty where it's just x squared, it's 1x squared always. And then you have the higher degree of difficulty where there's some coefficient there. Now, because I found the correct answer, I can erase that and erase that. And now how do I solve this?
You basically put them into like separate type of equations and you add 1 to one side and x equals
So what are
positive.
my two solutions after you do all that?
1 and negative 1/2.
Same thing we got from the quadratic formula, right?
Mm-hmm.
In other words, let's see if I can do this. Yeah. When I go back up here, when we ran it through the quadratic formula, we got 1 and negative 1/2. We didn't actually need the quadratic formula because we could factor it, and it's always easier to factor than it is to use the quadratic formula. But this is a good example of where they both produce the same solution, as they should, always. All right, now number 2, I can't factor that. Well, first of all, what's the first step?
You have to move 9 over.
Yeah, you gotta, when you're dealing with quadratics, you want the other side to be 0, always, or almost always, not always. But now, notice that there's no way that's factoring, because I don't have a lot of choices. It's either x plus 3 times x minus 3, and that doesn't work, or it's x plus 9 times x minus 1, and that doesn't work. So factoring does not work here. So in this problem, I have to use the quadratic formula. What's A, B, and C?
1, 2, and negative 9.
Plug it in.
Negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 9.
Again, we have that negative C. And a lot of quadratics, C is negative, because otherwise you have imaginary solutions. But that negative screws a lot of people up, because we got a subtraction sign there, and that looks like the same thing, only we're not subtracting in the second case. Okay? And that's why I always recommend people do this part next.
So that should
Just
be
to avoid mistakes. So what's inside the radical now?
negative 36. Oh, 4 minus negative 36.
Which is?
40.
Simplify.
Over 2. Is it, okay, I have a question. If I have 2 positive 2's there, can I cross like them out?
You can, but let's simplify root 40 first, because that'll matter. In other words, next step is to simplify that and not worry about these 2's. Because what's going to happen is I'm going to pull a whole number out of there. What is it?
4 and 10.
So what's the answer? Root 40, what does it simplify to?
2 times 10.
Root 10.
Oh, root 10.
In other words, what you had, you said it correctly, you had root 4 times root 10. That's root 40. But root 4 is 2. So I can erase that with a 2. Now the whole thing's divided by 2. And now the answer to your question is yes, I can divide the top and the bottom by 2. What do I get?
-1 plus or minus 10.
Root 10.
Or root 10, sorry.
And it's all over 1, so that's my answer. And that's what x is equal to. So what's my real answer? In other words, what are the two answers for x?
-1 minus the root of 10.
Do the top. Always do it the same way. Work from top to bottom.
Oh, plus root 10. And then the other one is minus root 10.
Right. And it wouldn't matter which way you went. You could go bottom to top, but there's a lot to be said for establishing a pattern when doing math. You always want to do stuff the same way, even when you have choice as to how to do it. You know what I'm saying? Here, for example, x squared minus 9. What does that factor into?
X minus 3 and x plus 3.
And you always want to do it that way. In other words, that's the same as this answer, but you never want to do it that way. And there's a reason for that. It's because when you get into the difference of cubes or the sum of cubes, there's a pattern, and you want to be able to recognize that pattern. And the pattern is that the first linear term always has the same sign as you started with. So the people, when I ask this question, and the people that answer me x plus 3 times x minus 3, that's just as correct, but it's not helpful towards memorizing more stuff and harder stuff. Whereas when you discover a pattern on memorizing stuff, you want to stick with it so you don't forget it. And I really, really believe that that's really important. And that's why I start with the top and then the bottom as the next one. All right.
Can we do one of the graphing ones?
Sure. Which one?
Or I don't know. I looked at it earlier and I had no clue where to even start.
Well, let's start with A, 3A.
Mm-hmm.
Now, does this factor?
Yes.
No, there's no way it's factoring. Only because I would have to split it up into x minus, or x plus and x plus, and 1 times x is never going to get me as high as 4x. So it's useful to look at these factoring problems and be able to tell instantly that that won't factor. My first step, incidentally, would be to factor out the negative sign, because it's really hard to factor things with a negative x. What's the next term and the next term after that?
4.
Plus 4x. What's this term?
Minus 1? No, oh, 1. Just 1 plus 1.
Right. The thing you want to do when you do that is always check the moment you're done as to whether it's the same thing you started with. And the only way to check that is to distribute that negative sign to every one of these terms. And when I do that, I get minus x squared minus 4x minus 1, which is what I started with. Okay? Now, so what that tells me is there's no way it's going to factor. There's no way, because it's plus and plus, and I don't have any choices on what to put there, and that gives me 2x in the middle. So I can't factor this. I've got to solve it using the quadratic formula. Now, there's a number of ways to graph this, and what I have to do is ask you what they've taught you, because there's all kinds of choices here.
I don't remember this at all.
Okay. Well, I could use the quadratic formula to find out what the solutions for x are. But because it's not factorable, and I know that, I know I'm going to get an irrational number. In other words, I'm going to get something like minus 2 plus or minus square root of 15 or something like that. And how am I going to those are the zeros. I'm not saying that's the solution. I didn't go through the quadratic and solve it. But I know I'm going to get an irrational solution. Because if there was a rational solution, I'd be able to factor it. And that's the difference. When you can factor it, you get rational solutions, meaning no square roots. When you can't factor it, you always get a square root. Now, if this turned out to be my solution, that's my zeros, but gosh, how do I plot them on that grid? So that's not a particularly great way to graph quadratics, by finding the zeros. Maybe eventually we'll have to, but there's a better method. What are all quadratics? What are they called? What kind of graph does it make?
A parabola.
Yeah. And what's the most important point on a parabola?
The vertex.
What is the x-coordinate of the vertex equal to?
-4. Or no, yeah, -4.
Negative b over 2a. And the way to memorize that, if you ever forget that, is remember what the quadratic formula is. Well, the vertex is the first half of the quadratic formula. It's the minus b over 2a part. And that's huge, because if we can figure out where the vertex is, we'll know how to graph this thing. But this is only the x-coordinate of the vertex. Do we want to use the second equation or the first equation?
The second.
No, the first. In other words, because we're not factoring it, we're not going to try to even factor it. We know it doesn't factor. Then let's use the original equation. What's minus b over 2a equal to?
Minus -4 over 2 times a -1.
Does that simplify to?
4 over -2, so -2.
Okay. Now, that's huge, because I know the vertex comes, that's the line of symmetry of my quadratic. Okay? I also know, which way does it open? Up or down?
Down.
Correct. So if I can figure out the y-coordinate, I pretty much have it, right? In other words, whatever the y-coordinate of the vertex is, I'll know where to start the vertex, and then it's just a question of solving for two other points. How do I get the y-coordinate of the vertex? In other words, the minus b over 2a gives me the x coordinate. How do I get the y coordinate? Remember what f of x is. F of x is y.
So so then do you fill in
Yes.
negative 2 for x?
Yes. In other words, the y coordinate is f of minus 2. Which is minus 2 squared, and this is where you really need to be very careful. Notice how many negative signs we're looking at. I'm not even done, and I got 1, 2, 3, 4, 5 negative signs. So very, very easy to make a mistake if you're not very, very careful. So let's simplify this.
So wouldn't that be negative 4 plus 8 minus 1?
So the y coordinate of the vertex is 3. And now we know exactly, there's our vertex at minus 2 comma 3, and we know it opens down. Now, usually when they ask you to graph a quadratic, they want you to find 3 points, not just 1. At this point, I only found 1 point, right? The vertex. What's another point that's really easy to find?
0 or 1?
Well, typically you would find the zeros. But the zeros are going to involve using the quadratic formula on that and coming up with what are the x values of the zeros. And then I would graph them there and there, and I would have my 3 points, and I'd be able to graph the thing. But that requires a lot of work. We've already seen how much work it requires to plug into the quadratic formula. There's actually an easier way to get 3 other points here, or 2 other points. And that's to figure out what the y coordinate, what's the y-intercept? Remember, the y-intercept is where x equals 0. The x-intercept is where y equals 0. So make x equals 0, and what do you get?
You get y.
Which is, plug in 0 for x and solve that.
Negative 1.
Yeah, it's always the constant. In other words, these 2 terms always go away when you plug in x of 0. So that tells me that another point is right there. Now, knowing that it's symmetrical, I can now draw half of my parabola. What must this point be right there?
Negative 4.
This is 0 comma negative 1, and this is going to be negative 4 comma negative 1. And there's my 3 points, and I didn't really have to do any hard work at all. I didn't have to plug into the quadratic formula. Now, granted, I don't know what my x-intercepts are, so if she specifically says, graph it by plotting the vertex and your 2 x-intercepts, you'd have to do the problem differently. But if you just need 3 points, and in fact 3 points define a parabola, and that's all you need is 3 points. In the same way that 2 points define a straight line. 3 points define a parabola. So they usually ask you for 3 points. Some teachers ask for 5 points, but most will accept 3 points because that's all that really is needed. If I gave you 3 points and said this is a parabola, you'd be able to come up with the equation, or you should be able to. All right. Unfortunately, I have a 4 o'clock Quade, so I'm going to have to run.
All right. Well, thank you.
You're welcome.
Talk to you next time.
Okay. Bye-bye.
Bye.